heuristic and analytical. So under empirical, we saw two very popular estimation techniques, expert judgment and Delphi. And what was the differences also you all have seen. So today we will be moving towards the heuristic methods or technique for project estimation. Okay, so here basically the approaches are a little bit different. Okay, so what happens? Right. On different estimation models, we classified into two cases, like one is single variable model and other one is multi-variable model. So for single variable model, okay, basically estimates the various features or the characteristic project might have, okay, and also what can be some of the basic parameters which might be dependent on the while making the project. So how do we estimate then? What is the parameter which is basically dependent upon that? Okay, so this is given by this mathematical equation C1 into E1 to the power D. Okay, now what are these? So E is nothing but the features, the total number of features that might be there of the software. Okay, and estimated parameter is nothing but it's a parameter which needs to be estimated, and from this parameter basically we'll be knowing what are the various parameters will be there in order to find out the cost estimation of the system. Okay, now when we compute the estimated parameter, what it tries to tell us. Okay, so estimated parameter is basically a medium to compute the effort, the duration of the project to be completed, the staff required. All right, these things are the things which is required for calculating estimated parameter. Basically it's a dependent parameter whose estimation gives us the effort, uh, the time duration of completion of the project, how many resources would you be using. C1 and D are basically fixed values. Okay, and basically they are computed from these values are computed from past historical data. Now here this equation is basically for a single variable estimation when suppose we have only one variable only, let's say E. But if suppose we have a situation that it's not only just about effort or maybe about project, it's not like if you are finding effort, then it'll be E only will be for effort only. If you're finding only about the duration, the timeline of the project for completion, then only E value will be corresponding will be for this only. So just a single variable. But when we are going for multivariable estimation, then this will expand. So this will be C1, okay, E1D, then C2, E2D. That means suppose we are finding effort, also we are finding time duration, also we are finding the number of staff size or the human resources we need. So all those things, this equation will be having more literals, okay, you can say. Analytical estimation techniques, however, they can be used, okay, or found out, okay, using the results based on certain assumptions regarding the project. Okay, so unlike empirical and heuristic, analytical techniques have a very scientific approach. Okay, so how they do that? Let us see. So let's say, for example, one of them is Halstead software science, okay, an analytical technique. So here, Halstead basically gives this method where one can find the size of the system to be developed, the effort which will be required, and the cost required in order to make the system. Now, for this, he laid down four parameters which one can find using this to the cost required to develop the system: eta 1, eta 2, n1, and n2. Eta 1 is nothing but how many number of operators we have used in the entire project. Okay, so operator may be logical, it can be assignment, it can be scope resolution, it can be so many of them. Okay, relational, isn't it? So many operators are there, so different ones. Operands, how many variables, okay, how many um, type of data we have used, okay, how many data members we have used. So this will basically give me the numbers. N1 is again, it's the total number of operators which is used. So here N1 will basically compute not the uniqueness. In eta 1, it is computing the uniqueness. Let's say, for example, if I have two assignment, one relational, one logical. Okay, so it will take only one each. How many unique operators or operands has been used? But in N1 and N2, it will compute the total number of operators. So if suppose an arithmetic operator, uh, um, three different arithmetic operators has been used, so it will take like total three value only. But in case of here in eta 1, it will take just one only as the count, because it will be checking the uniqueness, okay, not on the total number. Similarly for operands also. So if one has to find the length of the program, then they can use using this equation n1 plus n2. Okay, so n1 is nothing but the total number of operators, and n2 is the total number of operands. If suppose someone wants to know the vocabulary, that means how good is to understand the code of the program, then in that case, one can sum up eta 1 and eta 2. Okay. Uh, if suppose you are concerned more about the volume, okay, how large is the program, then in that case, what you can do, you can find out using this equation, V is equal to N. So N, what is N? N we have already found out at the top, is nothing but the total length of program, okay. So N1 and N2, if we sum up, N1 again, if you go, it is nothing but total number of operators and total number of operands gives me the total length of the program. And if suppose length of the program, which is N, okay, and if I want to find the program vocabulary, the understandability of the program, then it'll be eta 1 plus. Now, if I want to find the entire program volume, then how do I find? I use this equation to find. So it's a very scientific approach. You can see everything is mathematically derived, isn't it? So the program volume will be N, capital N. What is capital N? It is the total length of the program log to the base of 2 eta. Okay, and eta is what? The total program vocabulary. So if you use this equation, you will basically find the program volume. The volume actually in the machine level will always be represented in terms of bits. You need to find the effort and time required for developing a program. So this equation will hold E is equal to V by L, where E is nothing but you are finding out the mental um, uh, discriminations required to implement the program. So mental feasibility or your reasoning power, how much if you are rating, so that you have to find out in terms of percentage, okay, and how much programming effort you have found, like you have used, so you have to use this equation. Estimation also can be found by using the this equation. So eta we have already found, it is nothing but the program vocabulary. So we just have to substitute the values and get the, these are not required, these so much of equation. So one example is there, let us see. So it will be helpful for understanding Halstead's approach. So suppose I have this equation, this program. So what is this doing? It is printing the average of three numbers. We are taking three numbers from the keyboard, from the user's choice, and then we are finding the average and printing it. Now, which are the unique operators we have? We have, this is a keyword mean, isn't it? This is also another one, which represents a function, okay? The bases are another one, okay? Int, then scanf, okay, ampersand, then these commas, semicolon, okay, these operators, plus, all these things, okay, division, okay, the printf. So all of them are unique, okay, they represent unique operators. What about the unique operands? So ABC is one of them. Then each one of them, ampersand A, ampersand B, ampersand D, sorry, ampersand C, they are unique operands. Okay, why we are not taking them to be same? Because this is basically the address. A and ampersand A is different. Ampersand A represents the address of A. So this is basically a unique operand. Ampersand B is the address of B. So that way. Then when I am adding A plus B plus C, I'm getting a result. So again, this is a unique operand. AVG is a unique operand. 3 a constant is a unique operand. And percentage D format specifies they are unique operand. Clear? Similarly, whatever I'm printing under the inverted commas, okay, here I'm printing a value. So this is a unique operand. Okay, so from here, if suppose I have to find, then uh, what is eta 1? So eta 1, I have to find, right, how many number of operators are there and how many number of operands are there. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 12, 13, 14. This is the total, right? So some certain things are being repetitive also. So we have to drop the ones which are repetitive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So look here, for this one, for the operand, 1, 2, 3, 4, 5, 6, this entire 7, 8, 9, 10, because all percentage D are taken only once, not 3 times, 10, and then 11. So number of unique operands are how much? 11. Operators also you do 1, 2, 3, 4, 5, 6, 7, 8, 8, 8. Okay, this one we are not taking anymore because already counted 8, then 9, 10, 11, 12. So we are having 12. So what will be the estimated length? So we can use that formula that there was this estimated formula. This is the estimated formula that we have used. So you can use this one. N is equal to N1 plus N2. Eta is equal to eta1 plus E2. You can use to for finding the program volume. Okay, it's estimated length. So you just have to input these values there, okay, in the given formula. Volume also length into log of this thing. Just check one. V is equal to N into log to the base of 2 eta. That means program vocabulary. So from there, code will be given, and from there, basically, we need to find. So in most of the exams, that is the COCOMO model. Okay, so this is also a model which is basically used for finding the project cost. Okay, so under this again, whenever we are finding out the complexity of this model, so again it is divided into three categories, that is organic, semi-detached, and embedded. Okay, so these three products or three classification basically like pertains to, you can say, different kinds of program, like some may be system based, some can be application based, some can be a utility based. So depending upon uh, the type of okay, or other maybe system based programs, and that will be system programs, correct? Okay, so the one who has classified basically Boehm's, okay, he has classified the systems into three kinds: organic, semi-detached, and embedded. So in organic, this type of uh, kind of application which is quite well understood. Okay, how you are going to develop. You are using a high level language, you have a well defined databases or maybe a server. Okay, you have human resources or the software development team will carry out the development process. Okay, and somewhere the team or the members have a fair knowledge of what they are going to do. Okay, in the charged basically this is basically a mixture of people who are both experienced as well as not experienced. Okay, so team members may have very limited experience here. Okay, and they may not be very much familiar what they are going to be developing. All right, embedded is something where the software you are going to develop will have a very kind of a strong interaction with the hardware. Okay, and things will work on a very machine level or maybe an assembly language. So this basically corresponds to the system level development. Now, COCOMO model was again developed by Boehm. So, COCOMO, full form of COCOMO is constructive model. Okay, so the software cost estimation in COCOMO is done in three stages: basic COCOMO, intermediate COCOMO, and complete COCOMO. Okay, so again here basically what we are trying to do is we are trying to find out the probable cost, empirical cost associated while developing a project. Okay. The basic COCOMO model, there are two parameters, effort and time of development. Okay. So the equation for these are like proven, already proven equations. So for effort, we are having A1 into code, okay, in kilo lines, okay, and PM is per like in per like one person is developed in one particular month. Okay, how much he has developed. Okay, so A1, A2. Kilo lines of code, that means 1000 lines of code. Okay, kilo is 1000. That means if there are 1000 lines of code, okay, if someone has written, so that is represented by KLOC. So if there's, let's say, 2000 lines of code, that means it is 2 KLOC. Are you getting the point? Okay. Yeah, so depending upon that, like how many kilo lines of code has been written in 1 month, okay, by a person. So that basically will help us to compute the effort which is being put by a particular software team or a developer. Then TDEV is nothing but the estimated time required to develop the software, and basically it is like expressed in months. Okay. Constant. Yes, yes. They are constants for each category, and that constant basically is put up in the lab or by the team basically who develops the system. So these constants can be, it can be days, it can be months, it can be years, depending upon the how they have basically sampled this entire approach of finding the estimation. Okay, so that is like unknown. That will be done by the development team in a real-time environment only. Okay, that constant value they will be taking. So the effort estimation is expressed in units of per month. Okay, it is the area under the per month per person month plot. It should be that. Okay. So in this case, basically person month curve. So this area is the number of people who are working on the project, and this is the time which is used for developing. So let's say this is in months. Okay, so in this phase, if you see here, that means at this phase, maximum number of people have actually worked in this project. Then some people, let's say, must have left. So there is a decline, isn't it? Then the project, like the time duration was like going on. So there was some like progress in the project. Okay. So this graph actually shows two things. One thing is that how much time it took to start the project, okay, from zeroth level, and at that point how many people were there. It went off as the time was progressing. Yes, the project also progressed, but in between, if you see, there was a rise, many people worked, the people continued for some period of time, there was a dip. Again, for some time they continued, okay, at this point, let's say from 50, 20 resigned, 30 are still in the project. So maybe they still continue. So this actually shows, this graph actually shows how many people worked in a particular period of time from start to finish.
Okay, so it may so happen that some did not leave. Maybe the responsibility only was in the designing. So that's why more number of people were there. Okay, so it so may happen that in the implementation phase, less people were required. So others, whoever has done the analysis, they were not required. That also may happen. Okay, so this actually gives us the idea of people and the time required to complete the project. Then if suppose you need to find the development effort, okay, then again these are classified into three categories. These are like fixed equations, you can say. Okay, so we have no choice but to remember them. So for organic, for small systems, it's this much, 2.4 KLOC to the power this one. For semi-detached, again, these values are there. So you can find out these values only if the kilo lines of codes are known. Okay, then only you will be able to find out. So then again, for estimation of the development type for different kind of softwares or system, these are fixed constants. But then effort, how will you find? Effort equation, I think somewhere we have used, no? Yeah, from here, right? So once we compute this one, once we know the value of effort, then only we will be able to find. Okay. Same thing for development time also, they are all interrelated. The COCOMO model actually is very good because other models were not showing how we can find out the cost for finding effort, development time, isn't it? We say theoretically, but practically there was no proven mathematical equation. But here that thing is there. Okay, so tomorrow I will continue with the rest of the COCOMO model. So I don't have much content. I think 30 more pages, and then I'll be wrapping up the software engineering completely. And regarding the lab of software engineering, there is nothing else except for drawing DFG and ER, which I've already said also. So many classes I have taken about DFG, almost 5 classes. So hence, I'll just give the questions for doing the lab of software engineering, and you will be given certain deadlines for submission, and then accordingly you have to submit.